Hello students. So we are again with the topic of the quantitative techniques, and this is the topic of assignment problem. In the last class we studied about that what is the assignment problem and how can be assignment problem be converted into an transportation problem or an LPP. So in the last class I told you that we have to not follow LPP or the transportation method to solve an assignment problem. We will follow our next method, which is known as the Hungarian method. So Hungarian method is the best method to solve an assignment problem. The objective of this session is that we will study about the assignment problem and we will study about the Hungarian method. So assignment problem, as we have discussed already, which has the number of jobs and the number of machines which are to be assigned. So the Hungarian method is basically based on a scientist named Hungarian. So there are the steps. The first step is the balance the problem if it is unbalanced. That means if the number of jobs and the number of assignments are not same, or the number of jobs or the number of machines are not same, that means we have to make it a balance. And balance we can make using the dummy row or the dummy column. The dummy row or the dummy column is basically then whenever it is needed. If I have one row less to the one column, then I will introduce the one dummy row, and all the cost of this dummy row will be zero because we are uh, taking as a dummy. So dummy we can't take any other cost apart from zero. So that means zero because it should not affect my solution. Next is that place an M at the cost element if some assignment is prohibited. If I am saying that this particular job cannot be given to this particular person, that means that is a prohibited. So I have to put M at this point. Convert into an equivalent minimum problem if it is a maximum problem. If it is a maximum problem, then we have to convert mandatory requirement that we have to convert this into a minimum problem because Hungarian method is used only for the minimization. We cannot maximize the problem with the help of Hungarian method. So first we will convert this minimum into a maximum problem into a minimum problem, and whatever the solution comes that will be applied to the maximum problem, so we can get the maximum solution. So how to convert a maximum problem into a minimum? We will subtract the each value of the matrix from a constant value, which basically we take as a highest value. So this, when we are converting this into a minimum problem, this is known as the opportunity loss table. The step 2 says that obtain zeros in every row and every column by row deduction and the column deduction method. So there are the two steps of a Hungarian method. That first is the row deduction method and second is column deduction method. So column deduction method is always applied after the row deduction method on the table which we have applied the row deduction. So in the row deduction method, what we do, we subtract the minimum element of a particular row from all the elements of that particular row. Similarly, when we apply the column deduction, we subtract the minimum element of a particular column from all the elements of that particular column. The basic purpose of this Hungarian method to apply this row deduction and column deduction is that we want a zero in each row and each column, at least one zero in each row and each column. The third step says that we have to cover all the zeros by the least number of horizontal oblique vertical lines. Means either we will use the horizontal line or vertical lines, or we can use both. If the number of lines, that is whatever the horizontal and vertical lines we will draw, if the number of lines are equal to n, that is the order of the matrix, then we will go for the step 4. Otherwise we will select the least uncovered value and subtract it from every uncovered value and add to each one at the intersection of the lines. And then we will again cover the zeros with the lines to find out that if you could go to the step number 4. Step number 4 says that we have to make assignments by considering zeros only. So in this Hungarian method, what we do, we select a row. How to make the assignments? So we select a row with a single zero. Either we will find out a single row or the single column in which there is only a single zero. If there are two zeros, we will leave. and we will go to the next row. So we will start with the row that if there is a single zero, then we will give the first assignment to this. When we are giving the assignment, or we are the criteria of a given assignment is the single zero, we put a square on this zero. And when we put a square on this zero, the corresponding zeros in that particular column, if we are giving the assignment in the row, then the corresponding zeros of that particular column should be crossed out. That means that should be cancelled out. It means that this particular job or this particular machine cannot be assigned to any other. So what we are doing, we are cross out the zeros if any in the corresponding row or the column. That means if we are selecting a row, that means the column will be deducted and the column then with the row. We will continue in this manner until all the assignments are made. If there are multiple zeros left in all the rows and the columns, select a zero arbitrary. So if there are multiple zeros and we are not able to find out a single zero, then we will take any zero and we can start from that. If multiple zeros in the rows and the columns remain, indicate the multiple optimum solutions. It means if we have the 2, 3 zeros in the particular column and we are not able to find out a single zero, that means there are the multiple alternative solutions. So let's take an example. This problem is given that we have 4 person A, B, C, D and the 5 jobs 1, 2, 3, 4, 5. These all the values are the time which are given in the hours. Now if you see the problem, there are the two x. One is A3, that means person A job 3 x, person C and job 4 is x. What does it mean? As we discussed that these are the probated assignment. That means the person A cannot get the third job and the person C cannot get the fourth job. These are the probated assignments. Now again, if you see that there are the 5 jobs and the 4 person, so this is an unbalanced assignment problem. So first we have to make it balanced. By for making it balanced, we have to use the dummy row or the dummy column. So if we have a less number of person, that means we have to use a dummy person. Now here if you see that this assignment is a balanced one because we have introduced one E as a dummy person with all the cost, all the time as 0, 0, 0, 0, 0. And what we did, we put M at the places of the probated assignments, which were denoting as the X or the cross marks. So we put M at the probated assignments. Now we will apply the row deduction step on this table. In the first row, the minimum element is 18. So what we will do, this 18 will be subtracted from each and every element of this particular row. So 27 minus 18 is 9. 18 minus 18 is 0. M will remain same. 20 minus 18 is 2. 21 18 minus 18 is 3. So this is my first row. In the second row, the minimum element is 12. So 31 minus 12 is 19. 24 minus 12 is 12. 21 minus 12 is 9. 12 minus 12 is 0. 17 minus 12 is 5. So this is my second row. Similarly, the third, fourth and the fifth row. Now, if you see this table, in this table, in the first column, I have to apply the column deduction step on this table. So column deduction step says that we have to subtract the minimum element of a particular column from each and every element of the particular column. So in the first column we have 0 as a minimum element, so this column will remain same. In the second column we have again 0 as a minimum element, so this column will remain same. So in each and every column we have 0 as a minimum element, so there is no need to apply column deduction step on this table. Now our 2 steps are over, so we have to move to the third step. What we have to do, we have to cover all the zeros with the minimum number of horizontal and vertical lines. So these lines are drawn and these are the 1, 2, 3 and 4 lines. Now the number of lines are 4, which is not equal to n, that is the order of the matrix, which is 5. That means th we cannot go to a step number 4. Step number 4 was that we have to make the assignment, so we have to deal with be with the step number 3. So in the step number 3, it says that we have to find out a least cost of the uncovered cost, which is 5, and this 5 is to be subtracted from all the uncovered values, that is 19 minus 5, 12 minus 5, 9 minus 5, 5 minus 5, and so no, this is the least cost 4. This 4 has to be subtracted, and this 4 has to be added at the intersection point. So one intersection point is this and one intersection point is this. So m will remain same, but this 2 will change as a 6. So this table comes out to be after deduction of 4. So a number of lines was 4, which is the smaller than the 5. The least uncovered value is 4, and resulting table is this one. So again, now in this table, what we have to do, we have to cover all the zeros with the minimum number of horizontal and vertical lines. So 1, 2, 3, 4, but this 0 is remain there. So this 0 can be covered as a vertical line or the horizontal line. So the line will be 5. Now the order of the matrix is 5 and the number of lines are 5. So this is my table on which I can give the assignments. Now to give the assignments, we follow the same concept which we have discussed. What we will do, we will find out the single zero in a particular row. So in the first row we have a single zero, in the second zero we have the single zero, in the third also, in the fourth we have two zeros, in the five we have four zeros. So starting with the first row we have single zero, we will give the assignment to this 2, this 0. That means we will put the square over here. When we are putting the square over here, we have to see that the zeros in the particular column. So we have to cross this 0. Okay. When we have crossed this 0, now this assignment is done. Now we will move to the second row. In the second row, this is the single 0. So we will give the assignment to this particular 0. We will put the square on this. And corresponding to this column, this 0 will be cancelled. Now we will move to the third row. And in the third row, this is a single 0. So we will give the assignment to this particular 0. Corresponding to this 0, the 0 of this particular column will be cancelled out. When we move to the fourth row, in the fourth row this 0 is already cancelled, so we have only left with the single 0. So when we are putting a 0 on this and giving the assignment, in this particular column this 0 will be cancelled. Now if you see that this 0 is cancelled, this 0 is cancelled, and this 0 is cancelled, and in the E we are left with the single 0. So this 0 will be given the assignment by putting the square on this. Now we can see the assignments are 1, 2, 3, 4, 5. Now what does it mean? So this means that the A job is assigned to the A person is given the second job, B person is given fourth job, C fifth job, D third job, and E as a dummy job, that the first job, the dummy person. Now we have to find out the total assigned time which will be taken by these all the people to cover all the jobs. We can consider the initial table which was given, and we can add the timing at these places. So the total timing will be 66 hours of this assignment problem. Now you can watch this video by saying that what is the concept of assignment problem. The recap of this lecture is that we have studied about the Hungarian method, how to solve a problem by the Hungarian method, what is an unbalanced assignment problem, how to make it a balance, and if any of the assignment is prohibited, what we have to do. So we have studied about the Hungarian method, the two steps, the row reduction step and the column reduction step. Now the question comes that why assignment problem is different from the transportation problem. What are the uses of assignment problem? What is the Hungarian method that we have discussed in this class? So you may discuss among your classmates that what are the questions, what are the solution of these questions. Now these are the books which can be referred to find out the more details of the Hungarian method to get more questions for practice. All the best. Thank you so much.